Hi everyone, today we're going to be solving Edexcel GCSE Chemistry Unit 4CHO/4CH1. Today we're going to be solving paper 1C, Specimen 2017 paper. In this particular video, we're going to be solving the entire paper. The diagram shows the structure of an atom. Name the central part of an atom. So the central part of an atom would be nucleus. Name the positively charged particle in an atom. The positively charged particle in an atom is the proton. State how the diagram shows that this atom is neutral. In the diagram, we can see there are equal number of protons and electrons. Give the mass number of this atom. So the mass number for this particular atom will be 3 proton plus 2 neutron, 5. Give the name of the element containing this atom. Use the periodic table to help you. 3 proton is contained by lithium, so answer will be lithium. Substance 2 can be classified as elements, compounds, or mixture. Each of the boxes in the diagram represent either an element or a compound or a mixture. Explain which 2 boxes represent an element. You can see box 1 is helium, which is an element, and box 2 is only hydrogen, which is also an element. So boxes 1 and 2 are elements because they both have only one type of atom or molecule. Explain which 2 boxes represent a mixture. We can see boxes 3 is a mixture and we can see box 5 is a mixture. So boxes 3 and boxes 5 are mixture because they both have different types of molecules. The list gives the name of some methods used in the separation of mixtures: chromatography, crystallization, distillation, and filtration. Choose a suitable method for each separation. Separating water from sodium chloride solution. So when we want to separate the water from a solution of sodium chloride, or imagine like seawater, we can do distillation. Separating blue dye from a mixture of blue and red dye. So since the blue and red dye are a mixture that is almost, it's very hard to separate, so we can use chromatography. Separating potassium nitrate from potassium nitrate solution. So since we have to get the potassium nitrate from the potassium nitrate solution, for this one we can use crystallization. Ammonium chloride decomposes in a reversible reaction. The equation for this reaction is ammonium chloride in a reversible process turns into ammonia gas and HCl gas. State how the equation shows that the reaction is reversible. The reversible arrow within the equation shows that the reaction is reversible. Some ammonium chloride is heated gently in a test tube. The diagram shows the test tube after it has been heated gently for a short time. So ammonium chloride heated at this end, and we can see X forming at this end, and Y is represented showing some sort of gas. Identify solid X and 2 gases formed in the region Y of the test tube. So the solid X would be ammonium chloride back again, and Y would be a mixture of ammonia and hydrogen chloride. Just to show you an equation how it works. Ammonium chloride, when it is heated, it turns into ammonia gas, NH3, and hydrogen chloride gas. Which change of state occurs in the test tube during heating? So during heating, we can see that the materials goes from solid to gas phase, and why we can call it sublimation or subliming. An experiment involving ammonium chloride can be used to show the process of diffusion. The diagram shows the apparatus at the start of the experiment with cotton wool soaked in concentrated ammonia solution at one end and cotton wool soaked in hydrochloric acid solution at another end. Ammonia has NH3, which means the molecular mass is 17, and HCl has a molecular mass of 36.5. At the end of the experiment, the white solid forms in the test tube. Explain which position A, B, C shows where the white solid forms. So first of all, we will choose the region C because ammonia molecules have lower molecular mass, hence they will travel faster than the hydrogen chloride molecule. So they will travel further in the same time as that of the hydrogen chloride molecule, and when they react back again, ammonia and HCl, when they react back, then they will produce ammonium chloride, which will be close to C. The percentage by volume of oxygen in air can be found by using the rusting of iron. A student sets up the apparatus to measure the mass of volume of oxygen in a sample of air. The student sets the experiment at around 70 cm3, connecting the tube containing 10 cm3 of air, a nickel plus containing about 100 cm3 of air wet iron fillings. An excess of wet iron fillings is used then needed. At the start of each experiment, the reading on the syringe is recorded and the apparatus is then left for a week so that the reaction is complete. The diagram shows the reading in one experiment and after the end of the experiment. Okay, so complete the table below. Syringe reading at the start is 76. syringe reading at the end. So we can see 45. Sorry, that will be 35. This is 30. Volume of oxygen used, 76 minus 35 is equals to 41. The table shows the results recorded by a different student in her experiment. Volume of air in conical flask 100, connecting tube 10, in the air in the gas syringe 80, final volume of air in the syringe 43. Calculate the percentage of oxygen in air using this result. So to find it, we are going to do percentage of oxygen. 80 minus 43, which gives us 37 cm cube. So 37 cm cube of oxygen present in the entire volume of air. Then we're going to divide 37 with 100 plus 10 plus 80, which is 190 cm cube. And then we're going to multiply that into 100%, which will give us 19.47%. Since we have to give our answer into three significant figures, all right, so it will be 19.5%. The table shows some possible causes of anomalous result in this experiment. Okay, we have to use this particular term from the box. Decreased, increased, and no effect. Each term can be used once, more than once, or not at all. So possible cause, wet iron fillings not in excess. Effect on the volume of oxygen used. So definitely volume of oxygen will be decreasing, so decreased. Apparatus left for 1 hour instead of 1 week. Definitely less amount of oxygen will be used, so decreased. Apparatus left in a warmer place for 1 week. Because the reaction is totally complete after 1 week, so it doesn't matter, no effect. A metal is added to copper to sulfate solution. A displacement reaction only occurs if the metal added is more reactive than copper. Metal plus copper to sulfate produces metal sulfate plus copper. Displacement reactions are exothermic. The more reactive the metal added, the greater the temperature rise. A student uses the following method in an experiment to compare the reactivities of different metals. Pour some copper to sulfate solution into a boiling tube and record its temperature using the thermometer. Add some metal to the test tube, stir with the thermometer. Record the maximum temperature of the content of the tube. He repeats the method using the same amount in moles of different metals. To make the experiment valid, he starts with the copper to sulfate solution and added the metal at the same temperature. Okay. State two other variables that must be controlled if the experiment is to be valid. So the student also needs to maintain the same concentration of the copper to sulfate solution in each case. And also the volume of copper to sulfate solution should be same in all cases. And along with this, a third point that we can write is that the particle size should be same for all sizes of the metal that are used. Another student uses the same method and 3 times for each of the elements E, F, G, and H. The table shows her results for these metals. For E, temperature rise in the first experiment 7, 4, and 8. So the average temperature increase is 7.5. That means we have omitted this particular result. Anyways, guys, the question says the student calculates the mean temperature increase for metal E and F. She does not include anomalous values in her calculation. Calculate the mean temperature increase for metal G and H, ignoring any anomalous values. Write your answer in the table. So we can see one of the temperature is 6, the other is 5 and 5.4. So we can use all of them. So for G, the temperature comes 5.5. Once we round it up, the temperature becomes 5.5. And for H, we can see 5.5, 11, 12. So this one must be anomalous. So 11 and 12, if we add and we divide it by 2, is going to be 11.5. Explain which metal is the most reactive. So basically, the metal that has the highest temperature change will be the most reactive. So metal H is the most reactive because it has the biggest temperature increase. Explain which metal is less reactive than copper. Metal F does not have any reaction, so must be less reactive than copper because there is no temperature increase. This question is about the elements in group 1 of the periodic table and their reactions with water. State why sodium and potassium are in group 1 of the periodic table. The atoms of the both elements have 1 electron in their outer shell. That's why they belong to the group 1 of the periodic table. A reaction occurs when a small piece of sodium is added to a large volume of water in a trough. Give 2 observations that you would make during this reaction. When sodium is added to water, sodium moves across the water. The sodium then melts. Sodium also gets smaller. It disappears. We can see effervescence. Bubbles of gas are produced and given up. So we just need to write 2 of the observations. After the reaction has finished, a few drops of universal indicator are added to the solution in the trough. Explain the color of the universal indicator. The universal indicator's panel color will be purple or blue because the solution becomes alkaline due to the presence of sodium hydroxide. What is the most likely pH value of the solution in the drop after the reaction is complete? It's most likely to be pH of 12. Sodium hydroxide is a very strong alkali, so it's definitely going to be a pH of 12. Give the name of group 1 metal that is less reactive than sodium. Less reactive than sodium will be lithium, because in group 1, the metals that are higher up in the group 1 are less reactive than the metals that are lower down the group. A small piece of potassium is added to a large volume of water in a trough. Give one observation that is made when potassium is added to water and that is not made when sodium is added to water. Potassium catches fire when it comes in contact with water. So when potassium comes in contact with water, it immediately produces hydrogen, but it also produces a lot of sparks. So the sparks ignite the hydrogen that is produced by the potassium, which then, burns with a violet flame. Complete the equation for the reaction of rubidium with water. So when rubidium reacts with water, it produces RbOH and hydrogen. So to balance the hydrogen on the right hand side, we can put a 2 that makes us 4 hydrogen on the right hand side. So we'll put a 2 in the left side for the water. That makes 4 hydrogen on the left hand side. But to balance the 2 rubidium on the right hand side, we need to put a 2 in front of the rubidium and 1 in front of the H2 molecule. This question is about hydrocarbon. The table shows the formula of some hydrocarbons. We can see the first one is methane. Let's name them. This is methane, ethene, propane, 2-methyl propane. This one is propene, and the last one is butane. Give the letters that represent hydrocarbon with the general formula CnH2n. So CnH2n means alkene. Here we can see B is an alkene, E is an alkene. State why B is the only hydrocarbon shown as displayed formula. B is the only one in the diagram that shows all the atoms and all the bonds. Explain which two letters represent isomers. We can see D and F. Butane and 2-methylpropane has the same molecular formula but different structural formula. So we'll say D and F, they have the same molecular formula but different structures joined together in different ways. How many of the hydrocarbons are members of the homologous series of alkanes? So D and E will be members of the homologous series of alkane. C will be that and A will be that. So four hydrocarbons. Many hydrocarbons are used as fuel. There are problems associated with this use. Explain how the combustion of hydrocarbon can lead to the formation of poisonous gas. During incomplete combustion of hydrocarbons, it leads to the formation of carbon monoxide, which is toxic. State why this gas is poisonous to humans. Carbon monoxide reduces the capacity of the blood to transport oxygen because it binds with hemoglobin permanently. Fuels used in cars often contain sulfur compounds which are removed. Explain how the combustion of these fuels in car engines still leads to the formation of acetylene. Nitrogen in the air and oxygen reacts inside the car's engine at high temperature, which causes the formation of nitrogen oxides. Those oxides that can react with water vapor in the atmosphere to form nitric acid. The copper to carbonate in the mineral malachite reacts with hydrochloric acid according to this equation. Copper carbonate reacts with hydrochloric acid to produce copper chloride, water, and carbon dioxide. Some students investigate the effect of changing the concentration of the acid on the rate of this reaction. The diagram shows the apparatus they use. There are cotton wool, there are hydrochloric acid, and there are malachite lumps that reacts. And then the balance gives the reading. This is the method they use. Set the balance to 0, add an excess of malachite lumps to the conical flask and replace the cotton. Start a timer and record the balance reading after 1 minute. Experiment is repeated using different concentration of hydrochloric acid. The mass and the number of malachite lumps are kept the same in each experiment. The table shows the result obtained in one of the series of experiments. Concentration of hydrochloric acid in mole per dm cube 0.6 to 2.0 and balance reading goes from negative 0.2 to negative 0.67. State why the balance readings have negative values. One of the reaction product is a gas and the reaction product escapes from the flask, which decreases the mass of the flask. That's why the reading comes in negative. The graph shows the result of the series of experiments. Concentration of hydrochloric acid plotted on the x-axis and loss in mass plotted on the y-axis. The circle point indicates an anomalous result. Suggest one mistake the student could have made to produce this result. The student may have recorded the balance reading too late, or maybe the acid concentration was greater than what it was recorded. That's why the value is greater. State the relationship shown by the graph. We can see the loss of mass is directly proportional to the concentration of the hydrochloric acid. Explain why an increase in the concentration of the acid causes an increase in the rate of reaction. You should use the particle collision theory in your answer. At higher concentration, there are more particles in the same volume of reactant, so they collide more frequently with the malachite particles, leading to a faster rate of reaction. The flowchart shows how ethene can be obtained industrially from crude oil. So we can see crude oil, which in step 1, it turns into diesel. Step 2, dodecane. Step 3, it turns into ethene. Step 1 involves the use of a tall column. Describe how diesel fraction is obtained from crude oil in step 1. Crude oil is heated at a very high temperature, example 500 degrees Celsius. And then the vapor enters the lower part of the column. There is a temperature gradient as we move up the column. The vapor in the diesel fraction rises up the column until it condenses at a height where its boiling point is lower than the temperature in that column. So the diesel fraction is removed from that particular fractionating column. In step 2, saturated compounds such as dodecane are obtained from the mixture of hydrocarbons in the diesel fractions. Explain why dodecane is described as a saturated hydrocarbon. Dodecane contains hydrogen and carbon only. That's why it's a hydrocarbon. And there are no other elements. And the reason why it is called saturated is because it contains only carbon-carbon single bond. Which of these formula is that of an alkane? Alkane has a general formula of CnH2n plus 2. So we will just have to see which one has the formula that matches with the CnH2n plus 2. C is an alkane because it is C11. So it is H11 times 2 plus 2, which is C11H24. In step 3, cracking is used to convert alkanes into alkenes. Complete the equation to show the reaction in which one molecule of dodecane is converted into 2 molecules of ethene and 1 molecule of another hydrocarbon. So C12H26 turns into C2H4, 2 molecules of C2H4 plus. So the remainder of the molecule consists of Ca, and 26 minus 8 hydrogen atoms will give us 18, C8H18. Alkanes and alkenes both react with halogens but in different ways. The equation for 2 examples of these different reactions are shown. Equation 1, ethane reacting with chlorine produces chloroethane plus compound X. In equation 2, ethene reacts with bromine and produces 1,2-dibromoethane. State the condition needed for the reaction in equation 1 to occur. Because equation 1 involves an alkane with a halogen, so we will require ultraviolet light. Because they say condition, it's better to write ultraviolet radiation. Deduce the formula of the compound X. So the compound X will be hydrogen chloride. So if they asked us the formula, so we'll write HCl. Draw a dot and cross diagram to represent the molecule of C2H5Cl. Show only the outer electrons of each atom. We'll show the 2 carbons are bonded together along with a chlorine, and we will also represent the 5 hydrogens because hydrogens are smaller atoms, so we can represent them smaller. So for example, the carbon is cross, hydrogen is dot, and chlorine is, in this case, a triangle represented on the side. So for the carbon, we will draw the crosses. Each carbon will have 4 crosses. And for the hydrogen, we're going to draw the dots. And for the chlorine, we're going to draw the triangles. Equation 2 shows an example of an addition reaction. State the type of reaction shown by equation 1. So equation 1 is actually a substitution reaction. So we'll say substitution. Alkenes can be distinguished from alkanes using bromine water. What color change occurs in the reaction between propene and bromine water? So bromine water has an orange color, and once the bromine water reacts with propene, propene has a carbon-carbon double bond, so the orange color will become colorless. A compound formed in the reaction between propene and bromine water has the percentage composition by mass as given below. Calculate the empirical formula of this compound. So our first step will be dividing the percentage by the relative atomic masses. So we will divide 25.9 with 12. 5 for hydrogen will be divided by 1. 57.6 for bromine will be divided by 80, and 11.5 for oxygen will be divided by 16. Then we are going to obtain the simplest ratio. So the simplest ratio would be obtained by dividing the answer by the smallest number from the answers. So the smallest number from the answer is 0.72. So everyone will be divided by 0.72. This gives us 3 carbon, 7 hydrogen, 1 bromine, and 1 oxygen. So the empirical formula of the molecule will be C3H7BrO. When aqueous solution of potassium hydroxide and nitric acid are mixed together, an exothermic reaction occurs. The diagram shows the apparatus used in an experiment to measure the temperature increase. So we can see a 25 cm cube measuring cylinder, 10 cm cube measuring cylinder, polystyrene cup, and we have a thermometer inside the polystyrene cup. Use the larger measuring cylinder to add 25 cm cube aqueous potassium hydroxide to the polystyrene cup. Record the steady temperature. Use the smaller measuring cylinder to add 5 cm cube of nitric acid to the cup. Stir the mixture with the thermometer. Record the highest temperature of the mixture. Continue adding 5 cm cube portions of dilute nitric acid to the cup, stirring and recording the temperature until a total volume of 35 cm cube has been added. A teacher advises the student to use 50 cm cube burette instead of the 10 cm cube measuring cylinder. Such 2 reasons why it would be better to use a burette instead of a measuring cylinder to add the acid in this experiment. So using a burette, we have the increment in volume, which is more precise. In burette, you can measure up to 0.1 cm cube very accurately. And the second one is that it avoids the refilling the measuring cylinder, because the measuring cylinder needs to be refilled every time, which will waste time, and thereby the reaction will have the time to cool down. The diagram shows the thermometer reading at the start and at the end of the experiment. At the start of the experiment, we can see a particular reading, and at the end of the experiment, we can see a particular reading. Okay, let's see the reading. 16, 17, 18, 18.6, 18.7, and here 24, 26, 26.8. So thermometer reading at the end, 26.8. Thermometer reading at the start, it's 18.7. So the temperature rise will be 8.1 degrees Celsius. Another student uses the same method, adding the dilute nitric acid from a burette. The table shows the result and the temperature of the mixture. The student's graph is represented below. Volume of acid added and temperature of the mixture. So we can see the volume of acid added and temperature of mixture. Both of the line intersect, and we can get the maximum temperature rise and also the volume of acid that causes the neutralization. Identify the maximum temperature rise during the experiment. Okay, very good question. Maximum temperature rise, theoretical temperature rise will be 28.8. Oh, my bad. So it's going to be 29.5 because this particular portion is 29. It's going to be 29. Identify the volume of nitric acid that exactly neutralizes 25 cm cube potassium hydroxide. So to find that, we'll have to extrapolate the line from the point highest temperature downwards. So this gives us 21 cm cube. The answer is 20.8. Guys, since they asked us to do it exactly, we'll have to do it very accurately. 20.8 cm cube will be our answer. Another student records the result. The volume of aqueous potassium hydroxide 20 cm cube, starting temperature of the aqueous potassium hydroxide 18.5 cm cube, maximum temperature of the mixture 30 cm cube, volume of dilute nitric acid 20 cm cube. Calculate the heat energy released in this experiment. C is equals to 4.2 joules per gram per degree Celsius, and the mass of 1 cm cube of the mixture will be considered as 1 gram. So to do these particular calculations, first of all, we will calculate the volume, or we'll calculate the mass of the mixture. So the mass of the mixture will be, for example, the 20 cm cube of nitric acid added to 20 cm cube of potassium hydroxide. So the total volume is 40 cm. Then we will have to calculate the temperature increase. The temperature increase is 30 minus 18.5 degrees Celsius, which gives us 11.5 degrees Celsius. Then we will have to substitute the value into the Q is equals to mc del T and calculate the heat energy that is released. The heat energy that is released will be, we'll receive it in joules. 1932 joules. But because our exam significant figure is 2 significant figure or 3 significant figure, so we'll have to write 1930 joules or 1900 joules. Guys, I don't know anyone will ever see this particular recording in this particular part. Examiner sets the mark scheme for the international GCSE exam such that you will lose mark, because in this particular answer, the question answer says 1900 joules, except 1932 joules, which is the original result. Now, if our exam, is based on 3 significant figure, then our value should be 1930 joules. Now, you be the judge how to deal with the situation like this. In another experiment, the heat energy released is 1600 joules when 0.04 mole of potassium hydroxide is neutralized. Calculate the value of del H in kilojoule for the neutralization of potassium hydroxide. So to calculate the value for del H in kilojoule per mole, first of all, we'll have to convert the 1600 into kilojoule. So 1600 joules divided by 1000 will give us the value in kilojoules, which is 1.6 kilojoules. Now 1.6 kilojoule released from 0.04 mole. So del H will be 1.6 divided by 0.04 kilojoule over mole, which gives us 40 kilojoules. Now, the twist is, because the energy is released, so this particular reaction will be negative, all right? So the answer will be negative 40 kilojoule per mole. So del H negative 40 kilojoule per mole. Many different salts can be prepared from acid. The table shows the reactant used in 2 salt preparation. Complete the table to show the name of the salt formed and the other products in each case. Zinc plus hydrochloric acid. The salt will be zinc chloride and the other product will be hydrogen. Calcium carbonate plus nitric acid. So this will give us calcium nitrate plus carbon dioxide plus water. A student uses the reaction between aluminium hydroxide and dilute sulfuric acid to prepare a pure dry sample of aluminium sulfate crystals. The equation for the reaction used to prepare the salt is aluminium hydroxide reacting with sulfuric acid to produce aluminium sulfate and water. The diagram shows the steps in the student's method. We have dilute sulfuric acid, we have aluminium hydroxide that is reacting with the dilute sulfuric acid. In the step 3, we are doing filtration. We are getting the filtrate, we are heating the filtrate, and then we are leaving it to crystallize. State 2 ways to make sure that all of the acid in the acid is reacted in step 2. We can use excess aluminium hydroxide because it is insoluble in water, all right? And we can stir thoroughly so that all the acid is fully reacted. And we will know that when all the acid is fully reacted, when there will be an excess of aluminium hydroxide. State the purpose of filtration in step 3. The filtration will remove the unreacted aluminium hydroxide. In step 5, the basin is left to cool to room temperature to allow the crystals of aluminium sulfate to form. State one method of drying these crystals. We can leave the aluminium sulfate crystals in a warm place on a paper towel. The student records this information about the reagent she uses in her preparation. Mass of aluminium hydroxide 3.9 gram, amount of sulfuric acid 0.09 mole. Determine which reagent is in excess, making use of this information and the equation in part B. At first, we will need to calculate the MR of the aluminium hydroxide. So MR of the aluminium hydroxide will be 27 plus 3 into OH, which is 17, equals to 78 is the MR of the aluminium hydroxide. Then we will need to calculate the amount of aluminium hydroxide that has reacted. So number of moles, aluminium hydroxide will be 3.9 divided by 78, which is equals to 0.05 moles. So this is more than, if we look into the reaction, we will see that it reacts in a ratio of 2:3. All right. So we will see, we get a ratio of 2:3. All right. And the sulfuric acid is in excess. Another student prepares 0.25 moles of aluminium sulfate. The formula of aluminium sulfate, Al2SO43. Calculate the mass of aluminium sulfate prepared. So we will need to calculate the MR of aluminium sulfate, which is 27 times 2 plus 32 times 3 for the sulfur, and then 16 times 12 for the oxygen, which is equals to 342. So the mass of the aluminium sulfate produced will be 342 times 0.25, which will be equals to 85.5 grams. The equation for another reaction used to prepare a sample of salt is lead oxide plus nitric acid producing lead nitrate plus water. In one experiment, the amount of lead to oxide used was 0.75 mole and the amount of nitric acid used was 1.5 mole. At the end of the experiment, the mass of the lead to nitrate obtained was 209 grams. Calculate the percentage yield of lead to nitrate in this experiment. So to calculate the percentage yield, we will divide 209 with 311. When we will divide 209 with 311, it will give us 0.631 mole. Now the expected, the amount, the mole that was used was 0.75. Since this particular reaction is working at a 1:1 ratio, so it should produce 0.75 moles of product. However, the reaction doesn't produce 0.75 moles of product. The reaction produces 0.631 mole of product. So 0.631 divided by 0.75 times 100 will be 84% percentage yield. So guys, the total for the question paper is 110 marks. We're done with this particular question paper, guys. Thank you for watching the video, and guys, in the next video. Bye-bye.